YAML, sklearn, utils, estimator checks, checkestimator. Description. This function is a core component of scikit-learn's testing infrastructure. It verifies that an estimator class conforms to scikit-learn's API conventions and best practices. This ensures consistency and interoperability across different estimators. Inputs. Estimator: the estimator class to be checked. This is the central input, representing the algorithm you want to test. Outputs. None: the function does not explicitly return any values, but it performs extensive checks and raises exceptions if any inconsistencies are found. Steps. Basic checks. Verifies that the estimator inherits from the appropriate base class, e.g. base estimator. Regressor mixin. Classifier mixin. Checks if the estimator has the required attributes fit. Predict. Score for supervised models. Ensures the presence of getParams and setParams methods for parameter management. Data-driven checks. Tests the estimator on various data types. NumPy arrays, pandas data frames, sparse matrices scipy. Verifies handling of different data formats, e.g. numeric, categorical. Parameter checks. Asserts the correct parameter types and values. Validates parameter consistency during fitting and prediction. Result validation. Asserts the expected shapes and types of prediction outputs. Checks that the score method provides meaningful evaluation metrics. Cross-validation checks. Ensures compatibility with scikit-learn's cross-validation tools, e.g. crossval score. Metrics. None: the checkestimator function does not provide direct numerical metrics. It indicates success or failure through exceptions. Visualization plots. None: this function primarily focuses on functional correctness, not visualization. Fine-tune parameters. None: this function is not intended for fine-tuning parameter values. It's focused on verifying API compliance. Uncertainty methods. None: this function does not explicitly handle uncertainty quantification. Challenges and fixes. Challenge 1: estimator missing required methods. Sample use case that resulted in challenge 1: an estimator class is missing the fit method, which is fundamental for training the model. Fixes to challenge 1: implement the missing fit method. Ensure the method takes the necessary data arguments and updates the estimator's internal state. Challenge 2: inconsistent parameter types. Sample use case that resulted in challenge 2: an estimator expects a parameter to be an integer, but it receives a float, causing a type error. Fixes to challenge 2: update the estimator's parameter declaration to accept the correct data type. If necessary, implement type conversions within the estimator's methods. Challenge 3: incorrect data shapes. Sample use case that resulted in challenge 3: an estimator expects a 2D array as input, but receives a 1D array, leading to shape mismatch errors during fitting. Fixes to challenge 3: modify the estimator to handle different input shapes gracefully. Ensure that the data is reshaped appropriately before processing. Challenge 4: incompatible with cross-validation. Sample use case that resulted in challenge 4: an estimator's fit method modifies the input data in place, causing issues when used within cross-validation frameworks. Fixes to challenge 4: ensure the estimator does not modify the input data in place. Create copies of the data if necessary to avoid unintended side effects.